Hi there, I'm Mr. Kemp. Welcome to the third session in the sequence of lessons about equivalencies of fractions, decimals and percentages. Today we're going to build on what you have done over the past couple of sessions and go a little bit deeper by looking at fractions and decimals in different contexts. You don't need any resources for this lesson apart from something to write on and something to write with. Now, in the previous lesson, Mrs. Harrison asked you to create some cards with fraction and decimal equivalencies for the ones that you need to just know off by heart. Now, we're going to have a little practice of these to see how much you remember. You ready? My first card says 1/4. What decimal equivalent do you think is on the back of my card for 1/4? That's right. 0.25 is equivalent to 1/4. Let's have a look at the next one. I've got 1/2 on the front of my card. What do you think is on the back? Shall we see? That's right. 0.5 is equivalent to 1/2. My next card is 1/5. What do you think is on the back of my card? You got it? Shall we see? Of course, it is 0.2. Did you get that? Of course you did. You're amazing. And the final one, 1/10. What do you think the decimal equivalent to 1/10 is? Can you remember? Shall we see if you're right? Of course, it is 0.1. 0.1 is equivalent to 1/10. Well done, you've remembered a lot. Now, I would like you to have a look at this number line. Can you see the 0 and the 50 and the 100? 50 is exactly halfway between the 0 and the 100. It's been divided into two equal parts with that interval halfway. Okay. Now have a look at this number line. Can you see the relationship between these two number lines? Now we've got a 0 in both, haven't we? Now we've got a 50 here and we've got a 0.5 here. Can you see the 5 here and the 5 here? And here we have 100 and here we have 1. We can see that digit being the same in both. They've just got a different value. Okay. Now let's have a look at this number line. Can you see that it has been split into 4 equal parts now, into quarters? Okay, and we can see the one that has been split into 2 equal parts from the previous slide. Can you spot any similarities between these two number lines? Can you see they've both got 0? They've both got 0.5. They've both got 1 whole. This one has got 2 extra intervals. We've got this number here and this number here. How do you think we would say these two numbers? Well, we would say this number as 0.25. I wonder if you thought it would be said as 0.25. Now, 25 is a whole number, and we're working with decimal numbers, and with decimals, we just say the digits one at a time. So we say 0.25. So what do you think this one is? That's right, 0.75. Okay. Now, do you notice that these two have got 2 decimal places? You see the 2 and the 5, the 7 and the 5, but this one has only got 1 decimal place. Why do you think that might be? Why do you think that might be? So let's have a look at 100 being divided into 4 equal parts. We can see the 25. We can see the 50. We can see the 75. Can you see here the 2 and the 5 are here and they're here as well? We've got the 7 and 5 here and they're here as well. Here we've got 50, but we don't have 50 here. We just have 5. I wonder why that might be. Now, when we're working with decimals that end in a 0, so this would be 0.50, we can actually take away, we can remove that 0 because it doesn't change the value of this number. 0.50 and 0.5 are the same. So we would just read this as 0.5. Now, We know that this can be read as 0.5, but how else could we say this? Have a little think and write down as many different ways as you can to say this value. Pause the video now and come back when you've got some different ways of saying 0.5. Okay, right, 0.5, we can also read this as 5/10 as a fraction. We can also write it in words as 5/10. However, if we think back to when it could have had a 0, so it could have been 0.50, we can read the number as 50 hundredths too. Can you see? And we can say that in words also. Now, 5/10 is equivalent to 50 hundredths because we have scaled up the numerator and the denominator. That's not a very good arrow, is it? I hope you can see. We have scaled up the numerator and the denominator by 10. Can you see? 5 multiplied by 10 is 50, and 10 multiplied by 10 is 100. So these two fractions are equivalent. Okay, so 0.5 can be said as 5/10 or 50 hundredths. Let's have a practice at counting using both fractions and decimals. So let's have a look at this number line. Let's practice counting forwards in decimals first and then fractions. Okay, are you ready? Starting from 0. 0, 0.5, 1, or 1 whole. Let's go backwards. 1, 0.5, 0. Easy, isn't it? Let's try the fractions now. Starting from 0. 0, 1/2, 2/2. Now 2/2 is equivalent to a whole, isn't it? Because when the numerator and the denominator are the same, that makes 1 whole. Okay, and we can count backwards. 2/2, 1/2, 0. Very simple. Let's have a look at this number line, which has been split into 4 equal parts. Let's try the decimals first, starting from 0. Are you ready? Let's go. 0, 0.25, 0.5, 0.75, 1, or 1 whole. Let's go backwards. 1, 0.75, 0.5, 0.25, 0. I'm hoping you're saying it as 0.25 and 0.75, if you remember back to earlier on. Let's try the fractions now, starting from 0. You ready? 0, 1/4, 2/4, 3/4, 4/4, or 1 whole. Let's count backwards. You ready? 4/4, 3/4, 2/4, 1/4, and 0. Fantastic. You're a counting wizard. Oh, look at all these equal parts. We've got 10 equal parts now. Let's try counting forwards from 0 in decimals to begin with. Are you ready? Let's go. 0, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and 1. 1 whole. Okay, let's count backwards. Are you ready? 1, 0.9, 0.8, 0.7, 0.6, 0.5, 0.4, 0.3, 0.2, 0.1, and 0. Very easy. Let's quickly try the fractions, starting from 0. You ready? 0, 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, 8/10, 9/10, and 10/10. Backwards. Let's go. 10/10, 9/10, 8/10, 7/10, 6/10, 5/10, 4/10, 3/10, 2/10, 1/10, and 0. Fantastic. Well done. Now, let's count in fifths, forwards and backwards. We'll start with the fractions first, starting from 0. Are you ready? 0, 1/5, 2/5, 3/5, 4/5, 5/5, or 1 whole. Can we go backwards? You ready? 5/5, 4/5, 3/5, 2/5, 1/5, and 0. What do you think the decimal equivalents are? Could you use any previous knowledge to help you? Pause the video and have a go. Welcome back. Shall we see how well you did? Did you get any right? Could you spot any patterns? Can you see that all of these decimals appear in the tenths too? You can see we've got 0.2 here and 0.2 here. We've got 0.4 here and 0.4 here, 0.6 here and 0.6 here, and finally 0.8 here and 0.8 here. Why do you think this might be? Now, we know that the 10 times tables also appear in the fives, so this shows that the relationship between 5 and 10 continues into fractions and decimals. Now, you'll remember that Mrs. Harrison said there are some decimal equivalents that you need to know. Here's an example of this. Now, here we have a measuring cylinder. What do you notice? Can you see that our number line from earlier on is now a scale? It's no longer horizontal, it's now been displayed vertically as a scale. Can you see our unit of measure, our litres? We can say that half a litre is equivalent to 0.5 litres. Do you know how many millilitres this is? Think about how many millilitres are in 1 litre. Yes, 1,000 millilitres is equivalent to 1 litre, so 500 millilitres is equivalent to half a litre. Well done. Let's have a look at another one. So here we have our measuring cylinder, which has been split into 4 equal parts. Okay, just like our number line, it's just vertically now. So we can see that we have got 0.25 of a litre, 0.5 of a litre, and so on. And we can see the equivalence of millilitres here. Okay, so we can see that 0.25 or 1/4 of a litre is equivalent to 250 millilitres. And 0.5 of a litre or 2/4 of a litre is equivalent to 500 millilitres. And 0.75 of a litre or 3/4 of a litre is equivalent to 750 millilitres. Okay? And we can see the same in fifths. Can you see that our number line is just vertical now? It's on a scale on our measuring cylinder. And we can see the fraction and decimal equivalents of litres, of fifths of a litre. And we can see here the milliliter equivalents also of fifths of a litre. Can you see those? And finally, we have a measuring cylinder here, which has been divided into 10 equal parts, our tenths, which we looked at earlier on a horizontal number line. And again, it is just now being presented vertically as a scale. We can see the equivalences between the decimals and the fractions of a litre. And we can also see the milliliter equivalencies here also. So we can see, for example, 0.3 or 3/10 of a litre is equivalent to 300 millilitres. Feel free to pause and have a look and have a practice of these equivalencies on any of these measuring cylinders. Hey, can we see the intervals on this weighing scale? What do you think each interval represents? Count them and have a think. You can pause the video if you need to and come back. That's right, 1 kilogram has been divided into 5 equal parts. So each part is worth 1/5 or 0.2. So what measurement is the arrow pointing to? That's right, 0.2 kilograms. Could we say this another way? Of course, 1/5 of a kilogram or 200 grams. Now, can you see that the scale on a weighing scale is just a number line? It's just curved around. Sometimes we can see number lines horizontally. We can see them vertically like we did on our measuring cylinders, or as this weighing scale, we can see them curved. Let's have a look at another weighing scale. So what do you notice about this one? Can you see how many intervals there are this time? That's right, 4. So what does each interval represent here? Before we look at that decimal equivalent, do you think it's going to be greater than or less than 1/5 of a kilogram? Now we know that 1/4 is greater than 1/5, so that must mean that the decimal equivalent is also greater. So we have 1/4 of a kilogram, which could also be read as 0.25 kilograms or 250 grams. Fantastic. And there it is on our horizontal number line also. Now, I'd like to have a look at this number line now. You'll see that there are some decimals and fractions missing. Can you write down the missing values? Now, instead of you drawing your own number line, write down the decimal, then the is equal to symbol, then the fraction for the missing values. Pause the video now and have a go. Come back when you're done and we'll have a look at the answers. Okay, shall we see how well you did? Let's see. So what's equivalent to 1/5? Of course, it is 0.2. 0.4 is equivalent to 2/5. What is equivalent to 3/5? It is 0.6. I wonder what the missing denominator is on this next one. Of course, it is 5 because we are working with fifths. And the decimal equivalent is 0.8. Well done. I'm sure you got all of those correct. Well done. Now, I would like us to have a look at this meter stick. Now, I've chosen to use this one without any numbers on so we can focus on the number of intervals. What am I pointing at here? That's right, 0, or 0 meters, or 0 centimeters. I'm going to call it 0 meters. What am I pointing at here? That's right, 1 meter. Could we say this another way? Yes, we could say 100 centimeters because there are 100 centimeters in 1 meter, aren't there? How many equal parts has my meter stick been divided into? I can't quite fit it all into this screen. I wonder if I move back. Can you see all of those equal intervals? Those equal parts? How many? That's right, 10. So what is the value of each interval? Have a look and pause the video if you need to. That's right. Each interval is worth 1/10 of a meter. 1/10 of a meter. What is this as a decimal? 0.1. That's right. 0.1 meters. You can see. We could also say that each interval is worth 10 centimeters, couldn't we? So we have 0 meters, 0.1 meter. What would come next? That's right. 0.2 meters. What would come next? That's correct. 0.3 meters. Then, yes, you've got it. 0.4 meters. Then, yeah, 0.5. I can't even keep up with you. 0.5 meters. And then, yeah, 0.6 meters. Then, of course, 0.7 meters. Then, 0.8 meters. You're making me work very hard. And finally, 0.9 meters, of course. So we've got our full counting stick here, all marked out. And I've had one fall off. And can you see, we could also represent as fractions, couldn't we? Okay, so I could say 3/10 of a meter. Okay, or for example, 2/10 of a meter, and so on. Okay, it's just like our number line. We've just shown it on a meter stick now. Now, let's have a focus on some smaller intervals. Now, by looking at this tape measure, okay, can you see there's really small intervals there? What do these represent? Millimeters, that's right. So centimeters have been further divided into equal intervals of millimeters. Now, we're going to have a look at your practice activity using intervals within 1 centimeter. Have a look at these bar models for your practice activity. Each one has been divided into some equal parts and the whole for each is 1 centimetre. Think about what our smaller unit of measurement is. Give your answer as a fraction and a decimal of a centimetre, but as a challenge, can you also give your answers in millimetres? You have been absolutely incredible today. You've listened so well and have taken part fantastically. You should be so proud of yourself. and I hope you feel your maths muscles growing stronger each day. I hope to see you all again very soon. Keep up the great work. Bye.